So this is the 2010 Junior Cert Higher Level Section A. Just in terms of timing, in the exam you have 3 hours in total. You're asked to answer 10 questions. Ideally you'll aim to answer more than 10 because if you answer 12 they'll all be marked and your best 10 will be taken for grading purposes. So timing wise, you should be aiming to get your 10 minimum done in about 35 to 40 minutes, maximum 40 minutes, but ideally you'd be aiming for about 35. That would have given you about 5 minutes to read through the paper and have a look through all questions at the start. Just getting started here. Question 1 is always a label question, so you're given 4 items and you have to label what they are. So if I just zoom into this, so question 1, fill in the label for each selected from the list. So the first 2 lines are parallel, and if you're not sure of something, just work your way through it. The perpendicular is the very obvious one that comes next. And from the 2 remaining, collinear intersecting. These are obviously intersecting, these are collinear. And these are intersecting. Next up is perspective. So for this we are dealing with a vanishing point VP1 on the left and vanishing point number 2 on the right, where our vision of an object vanishes to a single point. The longer this object gets, the closer it gets to becoming a point. Now, I'm going to need my set square for this, and we'll just start joining the points together and see what we get. So first off here, I'm going to just have a look at my little graphic that's given. I can see that there's a little extra prism added on here, so I'm going to try and see if there's some detail I can fill in for that. First off, I could join that point back to the VP. I might just use sliding set squares for vertical lines here. Set up what a vertical line is and slide along. Now there's a construction given right there, but there's also a solid edge given here at the right hand side. If I line up with my vanishing, I have the base of that prism, and the final part to this now is up along the ridge of this roof all the way out until we hit this vertical construction line. So sometimes we're joining points back to vanishing, and sometimes we're taking already given lines and we're extending them. It'll always take a few seconds after doing one of these questions and just see. Now in this case here, it's finished. There is no hidden detail required, but it's very common in these questions that there's going to be some doorway, maybe there could be a doorway here, and that there's a little line vanishing back within that. So there's very, very often there's something there, such as that. Next, we have a developments question here. So the figure shows the plan elevation and 3D graphic of a dustpan. It is not necessary to include the handle nor the back surface. So what we're looking at here is just the 5 surfaces around the development. Now this time I'm going to again use my sliding set squares here. Just set up with the border of the question. And I'm going to stretch out based on the plan. In plan I can see the main central axis of the object, and a linear development will go perpendicular to the axis of the object. While I'm here, I'm going to take any of the other key points that are given. And I just start off with a random position, let's just say there. A little bit of labelling will help me here. Now, we start off, as always, with any development with the shortest possible seam edge. Now, the graphic here is handy for that, so I'll be sending that one. I could use the one on the left or the one on the right. Either way, that's the shortest seam edge. I'm going to start with the one here on the left, number 1. I want to open it so that I'm viewing the inside, so I'll work down to 2, 3, 4, and 5. That's the way I'm going to work around this. Number 1 here at the left being the shortest seam edge. So on my development, I'm going to start off there. That's edge number 1. The perimeter of the object is shown in the elevation. It's a regular pentagon, so I can take the distance there from 5 to 1. I could have taken 4 to 5 or 3 to 4. I can take any of them, and I'll just set them off. Now, my labelling is really important here, because a lot of people would make the mistake where they go to point 2, 3, 4 and 5, and then they'll stop. And they'll forget that it has to start and finish on the same seam, so you have to come back to point 1. Once again, sliding set squares are in for this, and you can stick the page on and use your T-square if you feel like it. That is no problem. You will get sufficient accuracy in these questions with sliding set squares. Now, if you need to just do them slowly and label one at a time, that's fine. I'm just going to reference from the elevation down to the plan and see how far it goes, realizing as well that there'll be marks here for the correct line types. So long, double, short. Three. There we go. Get heavy in the back edge. I don't need to leave any fold line because it does say in the question that there's no need to include the back of the object. And I can heavy in around the front of all of these. Oh, that's the finished developments question. It's there. That's question 1, 2 and 3 done. Question 4. The elevation and end of a writing desk are shown on the square grid. Complete the pictorial sketch, colour or shade. The completed sketch. Now, colour or shade, lots of people will do the sketch, but they'll forget to add the colour or the shading to it. What we're looking for here, so, is this. We're just looking to take the proportions of the original object on the square grid and apply it to the isometric grid. Now, I'm going to just quietly work away through this, just counting up the squares on one, applying it to the other. final part that's missing here is just this cross member between the two back legs of this table, and I think the line that a lot of people might miss would be from this top surface of that cross piece here. Now, there we go. So, colour or shade the completed sketch. Now, look, some very simple shading will do here. Just take your, if you have a HB pencil, great. If it's just the H, that's okay. Take your H pencil. We'll just go a little bit heavy on the front edges. Here, we might suggest that the light source coming from the back here. We'll go a little bit heavier on the front, any front facing edges. Go for some light shading up top. An area like this is going to be partially shaded by the top of the object. And if the light source was coming, I'm just making up my own light source. You can just make up whatever you like. It makes it look a little bit more realistic if you have some form of light source. It's a very light shading onto this side right here, and then I'm just going to leave it at that. We could add shadows on the ground if we wanted. I'm just going a little bit heavier down the lower end legs, which gives, it almost grounds the piece. There we are. So something like that will definitely achieve you full marks. Next. The figure shows the logo for a jewellery shop. Draw a new logo similar to the given logo with length AB increased to AB1. So similar means the same proportions but different sizes. So it's going to be the same proportions and it's going to be the same orientation, but it's just going to be different dimensions. The main thing here is angles don't change. So what I can do is, I'm going to start off here with sliding set squares. Now, AB has increased to AB1. I'm going to take up point 1, I need point 2 and point 3 on this new larger drawing. So what I'll do, I might as well start off actually with just a horizontal. So from the original point B across to point 3 was horizontal, and it's still going to be horizontal. Next, from B up to point 1 was at this specific angle, and using my sliding set squares I can set that same angle again. Now getting this next point is the key part here. I'm going to do an increase now, an enlargement from point A through point 1 up to the new position, point 1. I can do the same if I want to up through point 2, and I can do the same up through point 3. So that's a proportional increase in size there from point A, extending through point 1 up, through point 2 up, and through point 3. And then my drawing is nearly complete at this stage. I'll just take my original horizontal. I'm going to take that across from point 1 to 2, and now I just have to join the dots. There we go. Next, bit of a maths related one here. So the Cartesian coordinates, so the x and y axis are marked as intervals of 5 units, and we already have a kind of key point where a lot of people will forget to read the question. They're going to take it that it's 1 unit or 10 units, but they won't read the question and realise that it's 5 units. So write down the coordinates of the vertices of the triangle ABC. Now if you feel more comfortable, just work up along and give a quick label there of 5, 10, 15, 20, and work up along the y-axis in the positive direction and go 5, 10, 15, 20 if you want to. Now if you're very comfortable with these, then there is no need for this. That's all I need right there. So the coordinates of A, I'll go x then y, so it's x is 15 and y is 5, 10, 15, 20. Coordinates of B, x is minus 5. Now let's put down x, y there, because that's always the order. X is minus 5 and y is minus 15. Coordinate of C is 15 minus 15. So the really common mistakes there, first off not reading the units, and second off probably mixing up the x and y side of things. So that's that one. That's 6 questions complete. On to the next. So the figure shows the design of a handle for a knife. The centres of the arcs are shown. Show clearly all points of contact. Now, a point of contact between any 2 circles is found by joining the centre points of the circles. So I'll just start off with some of the easier ones. So here on the left hand side, and similarly here on the right hand side. So where it transitions from this first circle into this second arc here, we get point of contact. Where it transitions from the same circle on the right into this arc right here, we get another point of contact. Sometimes you're doing these questions and it doesn't make sense. Some of the points maybe don't make sense, and if they don't, take the compass and stretch it out and see like what are they referring to. Well, in this case here, that's the one they're referring to, and maybe you can, then it might make sense of what's transitioning into what, if you wanted to take that second just to verify what you're looking at here. So we can see there now with just the little arcs I've added where it transitions from one curve into the other. And once again, I'll apply the same rules here. I'll join the center point up top here to the center point down below. I might just do the same when I'm at it here on this side. And we get one in there. The final 2, and these ones are, I suppose, a bit of an anomaly really. Will they be included in marking or not? But we'll drop them in anyway. The final 2 that I'd be looking at is where it transitions from an arc to a straight line is a point of contact. So definitely would be forgotten, but I'll just drop them in. So it's a horizontal line, so I'll get a vertical. It's a horizontal tangent and it's a vertical there to give us the normal, which gives me my final 2 points of contact. That's number 7 finished. Number 8. The plan and elevation of the desk lamp is shown. In the space provided, draw a freehand pictorial sketch of the desk lamp, colour or shade. So this one, I'm going to start off anyway, because it's a round object, I'm going to start off by doing what's called crating. So I'm going to just crate in everything. That just basically means start everything off with squares and rectangles, because it's so much easier to do. So I put the base of this into a cylindrical base. Let's put it into a square. in the center. I need another little, I'm going to put another little square piece which will hold that main cylinder that goes up through. When I sketch it really lightly first, using all squares and cubes and so on, it really helps me to, it allows me to keep my proportions right. It allows me to keep the proportions and the direction of the object correct, so it's a little bit easier to work with. I know that that hemisphere up top is going to overhang and overshadow a lot of this, but I'll just kind of get my proportions somewhere near correct first. That would be the top of it, roughly maybe around there. Now, based on that, the top is bigger than the base, but if I just draw the base coming up again. And then if the top is bigger, I'm just going to offset, just step off a little bit further again. So there's quite a bit in it. Now to get the key points where the circular object touches, there we are. So we start off by just roughly dropping in the bases of all these circular objects. And tempted to go for the rubber just to clean up some of these, but I'm going to just leave it and see what it looks like after. I need this spherical head on this as well, so that's just, there's no real method to that. It's just if it looks right, it is right, really. There we are. So that's the first part of the question. I have done a freehand sketch of the desk lamp and colour or shade the sketch. I suppose they did include the cable, so I better drop that in as well. Colour or shade. So the first thing is, like the previous one, pick a direction for the light. So I'm going to just pick a light direction down, just like this, which means that the back area around here is going to be much darker than the front because it's in shade. And as we get around here, it gets lighter because it's starting to come into light. A little bit like that. This cylinder here is the very same. The back area of it is in shade. And as we come around, we're coming into light. A lot of this is going to be also covered here by the main stem, so there's a shadow being cast there. There's also, because of the direction the shadow is going to be cast out along, with the main, that hemisphere head of the object casting another shadow. Just add a little bit of shade around the ground. I might clean that up and add a little bit more after if I have time. The hemisphere is next, so if I just go along with the curvature of the object here, I'll go a little bit heavier down below again, and as I work up towards this top area here, I'm going to leave that completely light. I'll just go a bit of shading, heavy down below where it's away from the light, and a bit brighter as we get up along. There we are. I'm going to just leave it at that. Okay, so colour or shade the sketch, that's done. I never really take out colour and pencils for this, just shade it in with the pencil and that's it. Next, write down any 3 CAD commands used to edit the figure shown in the sequence below. The first one there would be to trim or trim entities. The second one there is adding a chamfer. The third one is a sketch of a circle. So we'll just drop down sketch. Circle. And the fourth one is making it 3D, so extrude boss. That's that question finished. If you know your CAD commands, they're very, very easy questions when they come up. And unlike the previous one, which I probably spent 5 minutes at, in this one we spend about 30 seconds. So that's question 9 done. On to question 10. The figure shown shows the outline plan and elevation of a crane and a load ABC. The 3D graphic is also shown. Complete the elevation of the crane and the load in its rotated position, shown by the broken line in plan. So a bit of rotations in here. First off, where does it pivot? So the main pivot of this object goes from point 1 to point 2. That is the hinge. The hinge appears as a point view right here in plan. I have my original position and I have my rotated position. So the first key rule when it comes to rotations is once you have your labelling done, we'll bring all parts of the object and project them onto the original position first. From the original position, we'll rotate them about the pivot point. Until we hit that new position, or the rotated position. And now we'll project them back up to the elevation. Next, I'm going to bring them across, and just remember the simple little rule that heights don't change. So as an object pivots about, it does not change in height. Now, point A, if I just label now before I go any further while I'm set up with my set squares, point A is the furthest away. Point C is the nearest. Point B is this one here. And if I just call that point 3 there, so I have 1, 2 and 3. 3 is the second last one here, so I'm going to bring point 1 solid all the way across to 3. And now I can just fill in my triangle, which is the load on the crane. And finally, the tie or the rope. So that's that one finished. Next up here, angles. And the first one there shows regular pentagon, and to make that up it's going to be 360 degrees divided by 5, which gives us 72 degrees. This next one here then, we're just given this object that's inscribed within the circle. I think the immediate thing you're rushing to do is either say it's probably the same angle as the 100 or it's half that, but either one won't work. So what we're looking at here, well, inside any four-sided figure, the 4 angles have to equal 360 degrees, okay? So inside any four-sided figure like this, what are the angles? So one of them is 100. When we look at a triangle that goes through as a diameter line base, through the center of course, well, all triangles based on a diameter line touching the circumference of the circle have to have a 90-degree outer angle. So if I apply that little bit of understanding that that's 90 degrees there, and again based on the diameter line, this triangle has a 90-degree angle here. And now I can just do my maths up above. So if I have 100, 90 and 90, that's 280 degrees. And then I'll have 360 degrees minus 280 is an angle of 80 degrees. Does that look right? To me it does. It's less than 90. If you want to verify that you're correct, grab the protractor, drop it in. Okay, so 80 degrees is the angle right there. Next, number 12. Complete the plan of the truncated pyramid shown. Now, truncated means cut. So the pyramid is cut. That's where the apex would be, right up at the top, but it gets cut right down along. Quite low here and a little bit higher here. If you want to, just start off with a bit of labelling here. That's point 1, 2, 3 and 4. When I view up to my elevation, 1 and 2 fall exactly on the same point, and the whole face up to 0 being the apex, the whole face from 1 to 2 to 0 appears as an edge view, which is very, very handy for solving this question. So I'll just grab my 2 set squares again, set up my sliding set squares there based on the apex. Now, the full face from 1 to 2 up to the apex, that full triangular face appears as an edge view and it gets cut at that point right there. So I can just project that down. This full face here from 3 to 4 up to the apex appears as an edge view and gets cut. Slip in there. It appears as an edge view and gets cut here. And after that we'll just join the dots. If it helps you to understand this, maybe just for now, for the practice work, you should just add a little bit of colour. So that's the cut surface right there. It's appearing as an edge view just up along here, and we can see our cut surface. So there is number 12. Final 3. 13 there, a 3D graphic of a bridge is shown. The planned elevation of a bridge is shown. Sorry, a 3D graphic of the bridge is also shown. Projecting auxiliary elevation on the X1, Y1 line. So sometimes with auxiliaries they'll give us the projection angle, and in this case they did not give us the projection angle. They gave us the X1, Y1, which is no problem to work with. So I'm going to set the angle of the X1, Y1, and I'm going to use the 90-degree side of my set square here. I know that all projections are at 90 degrees to the XY line. So there's a 90-degree angle there. Now I'm going to project up every detail, starting at the extreme left, extreme right, and all them hidden lines in the whole thing. There's going to be a lot of projections here. It's very, very common for a student to forget a projection as well. Now I'm going to just I'm going to hold my set square, my second one, where it is, because I don't want to lose this angle if possible. And I'll just take the two heights that are given. Overall height of the object being 1. I should have a projection here to get an accurate read of this, but I'm going to go with it. It'll be good enough for a short question. There's my second height. Now first off, the top of the object is just all the way. And the second one, I don't really know where that is yet, so I'll just drop it in. The full height of the object is seen on the extreme left and right. Now, time to start filling in the detail, or start figuring out what I'm looking at. So as I look in at the auxiliary, the primary face I'm worried about is the front face here. So it's a full solid top all the way, and it goes down to the ground, down to the ground. So it's a full solid top, down to the ground here and here. So I'm going to just get this face in as well. There. Now I have this left surface here as well. I've that done. Across the front, it's along the ground. It goes along the ground, then it slopes up, across, and back down. That's what I'm going to aim for next. I'm going to go along the ground up to here. I'm going to go from this point on the ground to this point up high. It comes across at a steady height as far as this projection here. And then it comes back down to the ground at this projection here. Next, I need to figure out what can be seen inside this area here, or if there's more. There's going to be hidden detail as well, of course. But I'll start with hidden detail, actually. I'll start here on this side. So it's on the ground and up high at the back. So it's on the ground there, and then it's up high here. So hidden detail. Go steadily across here. And then back down to the ground here. Any detail that's missing here now, well, a very common one that might be missed is that, well, the baseline of this actually has to be fully solid all the way through because of this inside surface here that I've just put an X on. That's it right there. Last detail that, or sorry, second last detail that a lot of people would miss on this would be a little bit of hidden detail along the top edge. And the very last detail is this back edge down here. Dropping that in is hidden. There's a lot of detail on such a small little object. Is that one finished? Second last question, number 14 here is the elevation of a bicycle rack and the wheel of a bicycle. So draw the wheel into position on the bike rack. So draw this wheel when it's in contact with both lines. First thing I'll just do here is I'll just take the base angle just so that I can get a perfectly accurate radius of what's happening. I'll just draw a radius line from the center out. First thing, if I'm putting any circle in to touch two lines, well, I'm going to bisect the angle because I want to see exactly where it touches both lines. We can just take it that that's the corner. So set your compass to a random size, strike your 2 points, and then strike again from both points. So there's my angle bisected. Next, I'm going to start with the angle given. I'll slide away from it a little bit, and I will pick a position anywhere at all out long and draw a 90-degree line. So this is kind of all linked back with solids in contact as well, actually very similar to some of the theory we'll have studied in solids in contact. I'll take the radius of this wheel and drop it. Once I have that radius added on there, there's my radius, added on here. Next thing I'm going to do is roll that wheel in towards the corner, and it's going to roll parallel to the ground. So as I said, I'm going to roll it in now by taking the ground angle or the base angle here. Going up to my radius and rolling it in. So that gets me the correct center point, but that is not all I need. I have my center point now here. I could go and draw the circle, but I don't like that. I prefer to show all constructions and point of contact. So I have kind of shown all my constructions, but I certainly haven't shown my points of contact. Now to do that, point of contact is always going to lie on the normal. So I will take the ground angle again and draw the first normal. I wonder, is it a 90-degree corner? It looks like it actually. It looks, maybe it's a little bit off, so I'll set the angle of the front of the rack here and slide down and draw that normal. That gives me both points of contact. And once I have both points of contact, I can just simply grab the compass at the center and draw my bicycle wheel. So show all constructions and point of contact, done. Final question on the exam is usually based on some sort of a bar chart or pie chart. So 12 students were surveyed about their favourite sports. The following were the results of the survey. So 6, 4 and 2 for football, hurling, basketball. Divide the given circle to represent this graphically as a pie chart, and in colour or shade the completed pie chart. So first things first here, our total number surveyed was it 12. Football is 6 out of 12, which we'll just break down later. Hurling is 4 out of 12, which will break down, and then finally 2 out of 12. 6 out of 12 is half, so it's going to be half of the whole object, which is kind of nice and easy. But if you want to work it out using angles, if there's 360 degrees total, if you have a calculator you can use it, but you probably won't need it. 360 multiplied by 6 over 12. 6 over 12 is a half, and 360 by a half is 180 degrees. 4 over 12 is a third, and a third of 360 is 120 degrees. And finally 2 over 12 is a sixth, and the sixth of 360 is 60 degrees. So there are the three angles I need to apply to this circle here. So I can start off. I'm just going to draw. Let's take the angle of my sheet again. No, I didn't really need to do that. It's just I think it looks better if it's going to be vertical, but it could be anyone at all, as long as half the circle through the center point is cordoned off for football. Football and 6. Next up, I just need my protractor for a second, and from the center point, taking that vertical as my angle, I can just, maybe I'll go off, it's upside down, might go off at 60 degrees one way. there's 60 degrees there. And I'll just check that the portion that remains is 120. So, hurling here is 4. And finally, basketball is 2. And the final couple of marks, this question would be to colour or shade. So just add some little bit of background colour on each of the 3 sections. Nothing fancy needed here, there's no weight or depth in this, so just a little bit of background colour on the 3 parts. That just makes them stand out, I suppose. There we are, that's it finished. So all 15 questions are done there, and that has taken 47 minutes. So I'd be hoping that when you start getting proficient with these, that you'll be able to get them 35 minutes, or between 35 and 40. Obviously I'm talking my way through it, and that's slowing things down as well. But if you are proficient and if you're efficient with your time, you should be getting through these in 35 minutes or so for your 10 or 11 questions maybe. That's it for now. More to come. Thank you.